Okay, when factored by grouping, when we have 4 terms, we're going to look at the first 2 terms and see if we have a common factor we can take out. I can divide both these by 9. So I can also look at the variables. How many n's can I take out? No, because I don't have 3 in this one. Exactly. So I always go with the smallest of the exponents. That's what I can take out. So I'm doing the opposite of the distributive property. Instead of multiplying right now, I'm dividing by it. So 63 divided by 9, 7. N cubed divided by n squared, n. And I always like multiply them back out to make sure I would get that. 63 n cubed, okay, plus 9 times 6 would be 54, and then I can take out both those n squared, so the variable's gone. Okay, if I multiply that back out, I get 54 times n squared. Alright, now I'm going to look at these two. Now, when you're doing the second ones, as far as the number goes, because you could take out a positive or a negative. So you got to ask yourself, remember, you want it to look the same as this. So I'm going to divide that by 7. Hopefully that works. 105 divided by 7. Yeah, so I'm going to divide both of these terms by 15. Now, if I just divide it by 15, I'm going to be left with a negative, and I want it to be positive. So I'm going to take out negative 15. And I can't take out a variable, right, because this doesn't have one. Okay, so 105 divided by 15 will get me back to 7, which is what I wanted, and then n. So negative 15 times 7n is negative 105. N. Okay, negative, I want to take out the negative, so this becomes positive, right? Because negative times positive is negative. And then 90 divided by 15, 6. So see, this is what I need to happen. That's why I looked at the number first. That's why I tried to divide it by 7, because these are big numbers. So I was like, well, hopefully 7 works, because that's what I'm supposed to get. And then I also took the negative out, because I want a positive 7. Okay, now that these two terms are the same, remember what I'm doing is this is one big fat term and this is one big fat term. And now what I'm doing is dividing them both by this common binomial. So I'm going to take out that 7n plus 6, and in the first term that leaves me with the 9n squared. And the second term it leaves me with the negative 15. Now, I have another common factor here. Does the answer key have a number on the outside? Because I just picked up on another, yep, it does. So look, you always want to ask yourself, can I go further? Here, 7 and 6, I can't go any further. But here, look, 9 and 15 have a common factor. So if I switch these around because of the commutative property, this makes more sense, because I'm going to pull out of that first one. So commutative property of multiplication, I just switched my two binomials. And now what I'm going to do is pull out that 3. Divide these both by 3. So 3 times 3n squared, right? And then negative 5. And now I can't go any further. Okay, and I can check this by storing some ugly number. I'm going to make all these n's x because it's faster on the calculator. And I'm going to use pi because it's nasty. I'm not going to get a coincidence with an irrational number. I'm going to take the original problem, 63x to the third power plus, that's minus, oh, I got to get out of the exponent, plus 54 times x squared minus 105 times x minus 90. Find out what it is. I don't care what it is. I just want to make sure it matches my answer. Because when you factor or simplify for that matter, you need equivalent. They should be equivalent to the original problem. So 3 times 3x squared minus 5 parentheses 7x plus 6 parentheses, they should be equivalent, and they are equivalent. So I've factored correctly.